Air quality in Rhyme, Red Nose Day 2019, because good air is not something to be sniffed at. Oh, I'll just turn this so I can see it. Sit and point it up. I've never been pointed that high before. Amazing. Okay, so, by Rob Miles, there's my Twitter handle and everything else. Oh, good man. Come and sit in the blind of the camera. And pay money and give a donut.
On the way out.
On the way out, okay. So you can take a box. Okay, so, here we go. Welcome to my talk in rhyme. I hope it helps you pass the time. Don't worry if it isn't funny. We're only in it for the money. There you are. And if the poetry makes you go nuts, cover your ears and eat more donuts. If you've money, we've got a bucket. Grab some cash and in it chuck it. Another way to pay for this ode is to scan our QR code. That actually works. Awesome. And if both these seem rather hard, just let us have your credit card details. But maybe not. Maybe not. Why air quality? This section is only important if you actually breathe. I'm rather good at breathing. I've done it all my life. Perhaps I've breathed for far too long. For details, ask my wife. But having done some research, I think it's time to share a bit of information on the quality of our air. It's better than it used to be. Of that, there is no doubt. It doesn't mean it's something that we don't have to think about. I'm really not here setting out to give you all a fright. Bad air need not be something that keeps you awake at night. Things aren't so bad, there is no need for you to wear a mask. But there are quite a few questions that we really ought to ask, like how can air be harmful in ways we cannot see? If I can see across the room, is it still okay to breathe? Nasty things out there of which you need to be aware are sized around the 20th of your normal human hair. Around 2.5 microns is about the size we're about. These tiny little particles can be made from burning fires. Another common source of them is wearing out car tyres. The problem with these nasties, why they aren't a force for good, is they can travel through your lung membranes and end up in your blood. A lot of folks are doing research and trying to conceive the dangers posed by nasty things in the air we breathe. We don't have all the answers yet. There's much work to be done, but we need to have some numbers that can drive our calculation. The numbers that are quoted in the press and on TV are not from proper readings, but made computationally. If we want to inform people and change the things they do, it might be nice to get some readings for the purpose of review. We might not use the stuff as posh as some say are proper, but as long as we are careful, we don't see this as a stopper. So we've made a few devices using sensors bought from China, just to see how they compare with sources that might be considered finer. How are we doing? Okay, right, everyone happy, fine. I have a strong belief in data as a force for useful change. We need quality information before our lives we rearrange. Getting values from some sensors is a way to get things going. Consequence of action is what people should be knowing. So let's build a few devices and advance the field of knowledge. With luck, we'll also learn a bit on working with technology. Close. Okay, I'm okay with that. That's good with me. So, measuring air quality. This section is only important if you like lasers. Okay? Now we have a change. The next bit is all haiku. Easier to write. What can we measure? Pollutants, there are many. We choose particles. These guys. Particles are small, 2.5 microns across. We need a sensor. Heater makes air rise. A laser shines through the air. Particles twinkle. Diode sees twinkles, sends signals to circuitry, detects and counts them. Packets pass data from sensor to computer. Sent via serial. Sensor makes numbers. Big numbers are not good news. Not that accurate. Maybe not exact, but good enough to work with. Shows pollution spread. Now we have numbers, we must make numbers useful. Store them in the cloud. I made some hardware, and some of it really works. Lots of pretty lights. So that's one of my air quality sensors, which is this guy here. That's the other one, which is this guy here. And this is the one that everyone wants to see. Go nuts, everyone. Close enough. This is, here we go, on to the next slide. Top hat demo. The world's first air quality measuring top hat. Okay, which, if I turn it on, here we go. It now wakes up, finds the Wi-Fi, please find the Wi-Fi, starts going. On my head. I've found there's a design flaw with this, which is that you can't see the readings that the system is generating. What we have, what colour is it? Oh, yellow's okay. We have a sensor on the back, counting particles, a WeMOS in there, which more in a minute, and a battery pack. And I can, this is, don't want to frighten anybody. In here, I have some of the deadliest stuff in the known universe. This is tissue paper, okay, it's deadly dangerous. If I scrunch some up near the air quality sensor, let's see what happens to the reading. Let's watch what happens to the hat. Please keep working. Maybe this tissue paper's worn out. It's going yellow, ooh, getting in dangerous levels. And if you keep going, it'll go, yeah, it's going to go red. So it actually works and measures. Oh, now it's going purple is the worst, according to our thing. So this is particles just made by squishing tissue paper, which is completely safe unless you bring it close to your face, okay? Yeah, these particles are hopefully not bad, otherwise I've just killed everyone in this room, for which I apologise. But what's happening at the moment is that the top hat is also talking through my phone to the interwebs, and later on in the lecture we'll see how the numbers get from this into the internet and how we can use them in our programs, which is awesome, but completely not worth a round of applause. I quite understand. Fine, okay. Excellent, thank you. That's lovely. Yes, it's and totally unprompted. That's really good. Thank you. Haikus are quite fun, but after a while they're great. Let's try something else. Sensor and sensibility. Is that an Arduino in your pocket, Mr. Dashwood? It is a truth universally acknowledged that a developer in possession of a requirement for an embedded application must be in want of an Arduino. It is also true that that quote did not come from sensor and sensibility, but from Pride and Prejudice. So sue me. It's also true that this font is very hard to read. Let's try this one. Okay, with the Boris Johnson, why the sketch from my head, badly based on When Stretched on One's Bed, a poem by the aforementioned writer, who won't be suing me at all. Whatever. Write a sketch from your head, the developer said. Use a platform that everyone knows, from a trivial care to a large code affair. The solution will be Arduinos. Lovely. Close inspection reveals a low price that appeals, though it has hardly no memory at all. But it's pleasing to learn there's not just one version, that's a version, ranging from the large down to the small. Look hard and you'll find something with Wi-Fi and a price you can easily afford. It's so easy to use, it's the one you should choose for your projects both home and abroad. This is my favourite chip. This is called a WeMOS based on the 8266. It's the guy that's powering this thing and this thing. Yeah, £2 a pop. Awesome. And it talks Wi-Fi. It's amazing. Keep going, Roberts. The WeMOS excels. C++, it propels. It's one of the best of its peers. If with sensor it's married, data can be carried to the cloud for our policy steers. So your data contains values, MQTT chains, to the cloud where the server resides. Server code can release meaning from what it receives, for the user to view and decide. And of course we could add some coloured lights and put it in a top hat because we're engineers. Hey! And we did. So, follow the data. The sensor makes serial data. This is to the tune of My Bonnie Lies Over the Ocean, but you don't want to hear me sing, do you? No, good, right, we'll move on then. The sensor makes serial data that's sent on a couple of wires. Then just a few microseconds later, on the processor is where it resides. Oh, watch this. Whoosh! That's awesome. Is it again? Oh yeah, go on. Whoosh! That's the data going from the sensor into the Arduino in real time. Awesome. It then makes a JSON collection that contains the things we want to send. Then over a network connection, at the server, its journey will end. So now, are you ready? It's exciting. Whoosh! Go. You see? I love PowerPoint. More than I should. JSON digression. JavaScript object notation. To give JSON its proper name, it's not really much complication. It's a technique for values to frame. For example, the particle reading. You can see that its given name, there it is, PM25. The value its name is preceding, which is like here, there you go, can be used by all systems the same. It's dead easy to understand. Even humans can read that. It's got temperature, pressure, humidity, timestamp, Latin long, which is actually my house. So, awesome. So that's just a bit scary. Moving on. Okay, so cloud storage. We now have some formatted data. We want it into a store. We need something up there to relate to. It's MQTT that we're looking for. So message queue telemetry transport, that's what MQTT stands for. Although I'm afraid I must report, knowing that doesn't tell you much more. MQTT is a thing with a broker. There's the broker in the cloud that sits in the middle and gets the things that devices have spoken. In our case, it's our sensor text. So these things just publish stuff into the cloud, and you know it's going to do it, don't you? There you go. Whoosh, there it goes into the cloud. So you find out you can do one thing, and then basically you just use it everywhere, okay? You get light in your eyes as well, which is quite painful. So, yeah. Subscribers can say that they want to get each message on topics they like. The broker then passes them on to the subscriber when each one arrives. So here we go again, there it goes, whoosh. So this thing pushes it up, that thing gets it down, and the broker does not store the data, it just sends it on when it arrives. It doesn't care what data relates to, that's down to those who published and subscribe. So the data store now has the readings, we can use them to improve what we know. If the websites we want to be seeing, then just fire up the server and go. You just pull stuff out of here and use it for whatever you like, because you've got the readings in the cloud now. So now we have the scary bit, otherwise known as the obligatory code demo, okay? Which is, yeah, checking the watch, yeah, okay, right, fine, yeah. Because I have to do some code. Code is good. It's one thing just to write an ode, but you need to see me run some code. This is not something I should shirk, and preferably the code should work. I'm going to show you something cool. Don't worry, this is no coding school, but I think that I should be allowed to show you some software in the cloud. A tricky bit, it seems to me, is sorting out MQTT. A broker is what we will need our sensor readings to receive. And once our broker is in place, we'll need to have some storage space. There's lots of hosts of that, I'm sure. But I like Microsoft Azure, because I'm a Microsoft MVP and proud of it, okay? Amazon's nice for books, lovely people, lovely books. Azure's where you want to be, I reckon. Not that I'm biased. Okay, so, Azure features, there are many. Quite a few don't cost a penny. Sensor data caught and then stashed without us spending any cash. IoT Hub links to our nodes, storage tables where the data goes. Capturing packets will be done by using an Azure function. Here you go, a million requests per month for free. Quite good. You might think this is. If anybody had some computer scientists, that would be. Sorry, I didn't mean you, Maggie. Sorry. Right. I know all the audience by name, which is kind of interesting. You might think the software needs a host, or else it's just a kind of ghost. A server needs to be in place to give your code some running space. But this is now no longer true. The cloud will host your code for you. Just send your code into the air, and where it runs, you just don't care. My function, it will do the bit when MQTT packets hit. When a new reading comes about, the function runs to save it out. As glue, the function does behave. Between remote device and data save, it works so well because it's able to write things in a storage table. Okay, so here we go. Finally, we see some code. I hope it won't your head explode. It's actually a C# class. We can represent a reading as. The properties that you can see, here they are, they look remarkable, that one's in the JSON, are for values that were received. A class like this is perfect for writing into a table store. A table store is basically a big list of class instances. That's all it is. And this is the class we're going to lob into it. And it's got all the things you'd expect to see. There's the readings from an air quality sensor, there's my temperature, there's my humidity, air pressure, and the weird stuff which I haven't got time to go into in rhyme, but nobody minds and nobody cares. These two guys at the top are how you index it, and I'm using the device name as one partition key and the timestamp as a row key in there, so I can find things and look through them if I wanted to do that. Functional living. This is the function that I wrote. It's something that I think's of note. Data receive is the function name. It's meaningful, or so I claim. The table in the data store, this is where it's going, holds data. That is what it's for. The link to the IoT hub, this is the link to the IoT hub. The connection is just a stub. This is basically saying, whenever you get a message on the topic devices from anybody on this IoT hub, then run my function. And this is like a placeholder. The real name is a big fat string that's stored in secret somewhere because that's the key to the castle. That's how I get my things wired up, okay? This is the received message thing. That's what's arrived. That contains the JSON which I've sent off from my WeMOS and holds the sensor JSON as a string. This is a log which I can fill, but my code wouldn't off the page. So I could, in the real one, I write a log entry when this happens as well, but it wouldn't fit on the page then. So I've chopped it out of the code. I hope you don't mind. Put it in the quality thing at the end. Great presentation. Pity he left the logging out of the thing. Do that. Fill the question in. It's all good. Okay, so this is the first line of the code that gets the JSON in the message stone. We ask the message, give me your bytes, turn it into a string, and then that's my reading. Okay, because MQTT just goes, I'm sending you some bytes, I don't know what they are, I don't care, not my job. You pull them out, make them into a string. And this line, as the code's proceeding, makes an empty echo. So I'm making an empty one of my class, called result. This line takes the JSON we got in our request values it slot. So it takes my class instance, and it takes my reading values, and it fills it up. So now my result now has all the numbers that came in down the wire. This time returns a new reading. The table store, it is because this guy is linked to a table store, bang, it just stores it. That's it. There is nothing other happening than that. And I can show you it working because if I go, if I go here and I go to, this is a wonderful little program called Azure Storage Explorer, and this lets you look at what messages are coming in from your device. And if I look in air quality readings, and then I do a refresh, they should have like music on hold when these things. I go right. So, AirQ top hat. If I do a refresh of this, let's look at the bottom one. Okay, that's the 14. There should be from 15. Sort on. It was working this morning, he said, with total confidence. Maybe my top hat has not found the network. Oh, there's a 15th one there. That was there. That was at what time was that? 10:30. And now on my air quality readings. The Wi-Fi in here doesn't seem to work on my. You're going to get cross with me if it doesn't. You might ask for your money back if this doesn't work. Let's restart. That usually works. Come on. No, I think it's not finding the Wi-Fi. That's sad. Let's just do a refresh. No. Oh well, never mind, I've got your money now, it's too late. So that's how it will work, and it does work if you have decent Wi-Fi.
I see 80 roam, and UOH guest, but I don't see AJ Hull from home.
No, I'm using my phone as an access point. So
right.
it's basically, it depends on what the 4G signal is down here, which is not great, looks like. So we can, this edit out a report.
I don't see that network.
It'll work in the, don't you? Oh, my phone got down then. We're going to edit this out of the recording. So if I turn my hotspot off, and then my phone again. This is, I wonder who it was that actually invented turning things off and back on again. Whether they actually, if they thought of patenting that simple action, it could be millionaires by now. No, still not grabbing hold, I don't think. One more try for luck. Well, maybe with a different audience it might have worked, just saying, putting it out there.
Is that our fault?
Yeah, exactly. Well, there's not that many, I could take you all. Okay, so that was actually, that was a code demo, and now we can move on. So it's quite a shock, it really is. A thing as small and cheap as this can power a proper networked app that's hardened against an attack, and it will scale for devices many. Cost at the start, there isn't any. So if you have a need for IoT, this is a useful place to be. You can buy your device. This is the thing that I find awesome. You can buy that for £2, and you don't have to spend anything else to get a connected device talking to the cloud, pushing values in there, and doing useful stuff. Because you get 8,000 messages per day for free on the IoT Hub, which I think is kind of awesome. And if you're a student, I think there's one student here, then you can get this even freer. Even more free, then you get more stuff for even more. So
finally, connected Humber, where we're at. In days to come, when we've all got 6G, they'll speak in phrases of awe, of a gang who will live on in history and smart city networking lore. They live round the Humber, love the place, but noticed the lack of a network. So they started designing and building at pace air quality monitoring to get work. And they've been and gone and kind of done it. If you look here, you can see sensors all around Hull. We're going to get some in the middle soon, and then we're going to start getting
that is live data coming from sensors around Hull at the moment. And as you can see, they're all green, which is good. If they all turn red, that's good. But we have actually watched stuff come in, go across the area, and go out again. And the question we're trying to answer, one of them, is where does the bad air come from? Do we make it? Does Scunthorpe make it? Does Dresden make it? We don't know. No one knows. They'll give you some readings they've simulated, but we know what those numbers are. They're coming from sensors like this and this and this, and they're in people's back gardens and on their sheds and whatnot, and they're pushing these numbers into the cloud. And we have some lovely software which takes the values. They actually use Whisper this, they actually use Amazon Web Services for this, Amazon hosting. But it will work with Azure as well. But we've actually done it, they've done it. My bit is tiny, but other folk have done awesome stuff. They're working hard and just for fun to find out how far they can get. They've learned a lot and have only begun. It's not long ago that they met. If you want to take part and learn something neat, come along to the C4DI. First and third Thursday each month when they meet. Come along, there's no need to be shy. This is our first piece of hardware. One of our members, this is what Brian designed. And it's basically a carrier board. There's my lovely WeMOS in the middle. And then these guys are connected to the air quality sensor, temperature sensor, power supply. There's a little bit of code in there to look after the power as well, hardware. And this is proper working stuff. And that's pretty much the end. No money refunded. Okay. Thank you very much to the University of Hull for hosting the event. Thanks to David at C4DI Eagle Labs for donuts. Thank you all, thank you both, for turning up. There's some URLs there you can go and visit. And the final rhyme, don't forget, it's not too late to donate. So thank you all for turning out. Awesome stuff. Thank you so much.